coal, the most important fuel in use today. Great Britain has the richest coal seams in the world, and this basic wealth played a major part in industrial expansion. More and more seams were opened up below the countryside, and around the mines, Britain's industries and towns converged. After 200 years of enterprise, Britain had world markets for her coal. At home in the industrial areas, there were 3,000 coal mines spread across the countryside. These mines employed 1.25 million men. In Britain, there were coal mines, giant industries, and busy towns. But all had been created with little thought for the country as a whole, for its social amenities. But that's an old story, and now here's a new one. It became clear that if Britain wanted her coal resources to last, she had to plan for the future. And now, here in Scotland, is the pithead of the new world, right in the heart of the countryside. The coal seams under the surface of the ground were proved by boring, and when their extent was known, mining engineers were sent to America and the continent to study all that was new in mining practice. The surface buildings of the pithead are built on modern symmetrical lines in the form of a square. One shaft is used for transporting men and the other for coal. Safety, efficiency, and economy are the three considerations of the plant. And there is no longer any reason for a new coal mine to be a blot on the landscape. The fountain serves a dual purpose, for it cools the water used by the winding machinery. But the plant is not restricted to buildings and machinery. The miners take an all-round course in mining engineering and supplement their practical training by attendance at the mining school near the colliery. They study geology, mechanics, physics, mathematics, and science. These students are being examined for a certificate in mining engineering. Besides this training, the miners are instructed at the colliery in the use of safety appliances. This class of firemen is having a lecture on safety matters. The instructor is demonstrating the diffusion of gases. The men are drawn from the surrounding villages, and the old practice of building homes near the pithead is abolished. Buses take the miners to their work. As soon as a new shift comes on, the miners go to the canteen and collect the food they will take with them underground. This usually consists of jam or cheese sandwiches, carried in a dust-proof tin box. These young miners do the lighter jobs near the pit bottom and elsewhere. The miners also take flasks of hot tea with them. They go from the canteen into the pit baths and change into working clothes. A separate locker is provided for each man's clean clothes. His working clothes are kept in another locker at the other end of the baths, which has a current of hot air running through it. The miner wears special protective clothing for his job, steel-capped boots, and a safety hat for head protection, and to which he fixes his lamp. The miners are supplied with numbered checks, which they take with them to the pit bottom and return when they finish work. Great emphasis is laid on each miner's personal safety. A cap lamp, worked from a light portable battery, is worn by each miner. This lamp leaves both hands free to work and gives a constant light. In this mine, one shaft is used for winding coal and one for men. The men use the downcast shaft. Each shaft is operated from its own winding engine house. Here again, the latest electrical braking and speed controlling devices have been installed to ensure the safety of the men. The cage holds 20 men at a time. The signal is given to the engine house, and the descent of the cage is controlled by the engineman, who keeps a constant watch on the indicators recording the position of the cage in the shaft. In 2 minutes, you are 1,200 feet below the fertile Scottish countryside. As the day shift arrives, they meet the men who have just finished work on the night shift, waiting to return to the pit head. The days of haphazard roof supports and blinding darkness are gone. Here are tube-like tunnels supported by steel girders, lined with concrete slabs and lit by electricity. Every effort is made to maintain the same degree of tidiness underground that we saw on the surface. At the shaft bottom, the foreman allocates each man to his working place. All the roads leading from the shaft bottom are ventilated by a clean current of fresh air from the downcast shaft. This air is circulated throughout the mine and is controlled from the fan house on the surface. The fan drives the air down this tube into the mine. The used air escapes up the upcast shaft. Meanwhile, the miners who came on shift are nearing the work face. As the extent of the coal seams was known in advance, the main roads were formed and the coal is now being worked from them. At the coal face, strict attention is constantly paid to roof support. These men are securing the roof at the end of the shift. Machines are used where possible underground, and this electrically driven coal cutter drives a cutting arm under the coal, making a cut along the face of the floor of the seam. The cutter pulls itself along by means of a strong wire rope. This type of machine is used in seams being worked by the long wall method. In the short wall method of working, a similar machine can be used to cut the coal either vertically or horizontally. The arm of the cutter goes into the coal in the same way, when it reaches the face, it cuts across. While this operation is going on, the driller starts drilling holes, which will later be filled with explosives. When the whole face is cut, the machine is withdrawn. The small coal in the cut is then removed with a long-handled shovel. Sufficient holes are drilled in the cut coal, and when the last one is completed, preparation is made for shot firing. A safety lamp is used to test for an explosive gas called fire damp. If present, a blue flame would appear inside the lamp. The miner extinguishes his cat lamp while he is making this test. The holes are then charged with explosive and sealed with clay. Stone dust is scattered along the face to prevent a possible coal dust explosion. When the men are well clear of the face, the shot is fired and goes another piece of coal. This giant shovel, called a duckbill loader, digs under the broken down coal. From the shovel, the coal is conveyed along a steel shaking conveyor. This conveyor has a reciprocating action driven by an electric motor and carries the coal to an endless belt conveyor. The shovel is on a swivel to enable it to pick up all the broken coal on this short wall face. On a long wall face, coal is loaded by hand onto the conveyor. The steel conveyors pass the coal to a belt. The belt conveyors pass the coal onto a main belt conveyor. This main belt carries the coal to the loading station, where it is filled into 3.5-ton steel cars. The cars are moved forward by machinery controlled by a lever. one man doing the whole operation. When 12 cars are filled, a diesel locomotive of 50 horsepower takes them to the tipping plant in the pit bottom. This way of moving cars is highly efficient, a locomotive being able to handle much more tonnage on the level than any other form of haulage. In this case, the locomotive is pulling 42 tons of coal. The cars are run into the tippler and are weighed automatically before being emptied. The couplings on the cars are of a swivel type, and any number of cars can pass through the tippler without being uncoupled. The tippler capacity is 140 cars an hour, and the operation, car moving and emptying, is controlled by one operator. The coal is tipped into a skip, which holds 10.5 tons of coal and is wound up the upcast shaft, which is on the south side of the square near the railway sidings. The skip discharges automatically on reaching the surface. The coal flows from the skip into an apron feeder and thence by a large belt conveyor to a screening device which grades it into 3 sizes. The small pieces of coal fall below, and the larger ones pass over to a picking belt, where the sorters pick out any stone. The picking belt is 85 feet long, and when all these men have done their task, only the best coal remains. Finally, the larger pieces are re-screened and pass on a loading boom into a wagon. The loading boom can be raised or lowered into the wagon to prevent breakage of the coal. While the larger coal is being sorted in this way, the small sizes are conveyed to the washing plant in a separate part of the building. The coal floats on the surface of the water and passes out of the tank. The stone sinks to the bottom and is discarded. The coal receives a final polish by water sprays before being sized and loaded separately into wagons. The discard from the tank is dumped by an aerial ropeway over a stretch of marshy land some distance from the colliery. Back at the screening plant lie wagons of coal sized and graded with care and precision. The rate of production is over 1,000 tons per day, but it is planned to raise and load 400 tons an hour just as easily. And all this is accomplished without spoiling the outline of the countryside. While this coal goes down the line to play its part in production, the day shift have arrived back at the shaft bottom. The cage delivers them safely to the pit head. These men have finished their 7.5-hour shift, but before going home, they have a shower at the pit baths. Inside the baths, electrically driven brushes take the coal dust off their boots. The miners' welfare is given great consideration, and emphasis is laid on health and cleanliness. Further, owing to the excellent working conditions and training, the accident rate is low. The miners here don't suffer from fatigue as in the past, and unrestricted, they enjoy their freedom at the end of a working day. And now that we have proof that there is no longer any necessity to associate the mining industry with ugly mining towns and chimneys belching black smoke, we can plan future ventures on the lines of this modern coal mine. This successful experiment opens up great possibilities for the future mining and miners of Great Britain. Modern coal mines, built and run on the lines you have seen here, will stand the test of time and guarantee a steady supply of coal for home use and for export to many countries overseas. In Britain, there were coal mines, giant industries, and busy towns. But all had been created with little thought for the country as a whole, for its social amenities. But that's an old story, and now here's a new one. It became clear that if Britain wanted her coal resources to last, she had to plan for the future. And now, here in Mont, and there is no longer any reason for a new coal mine to be a blot on the landscape. The fountain serves a dual purpose, for it cools the water used by the winding machinery. But the plant is not restricted to buildings and machinery. The miners take an all-round course in mining engineering and supplement their practical training by attendance at the mining school near the colliery. They study geology, mechanics, physics, mathematics, and science. These students are being examined for a certificate in mining engineering. Coal, the most important fuel in use today. Great Britain has the richest coal seams in the world, and this basic wealth played a major part in industrial expansion. More and more seams were opened up below the countryside, and around the mines, Scotland is the pit head of the new world, right in the heart of the countryside. The coal seams under the surface of the ground were proved by boring, and when their extent was known, mining engineers were sent to America and the continent to study all that was new in mining practice. The surface buildings of the pit head are built on modern symmetrical lines in the form of a square. One shaft is used for transporting men and the other for coal. Safety, efficiency, and economy are the three considerations of the plant. Britain's industries and towns converged. After 200 years of enterprise, Britain had world markets for her coal. At home in the industrial areas, there were 3,000 coal mines spread across the countryside. These mines employed 1.25 million men,